was called the world's first pregnant man, and today he gave birth.
But the court has gone the whole way, said there is an absolute constitutional right to same-sex marriage.
Hurricane Harvey is pelting the Texas coastline.
There is an increasing attack on freedom of religion, speech, and conscience.
Welcome to the Isschar Hour, examining law, policy, and culture through the lens of the Judeo-Christian worldview to help you understand the times and know what you ought to do.
Well, good day, good evening, good morning, whatever part of the world you are. Welcome to the Isschar Hour on MTM TV. My name is Wayne West, and this is my wife, Doreen. And this is the second of a two-part series we are doing on the 6 days of creation and the nature of time. Would you care to summarize what we did last time?
Well, last time we mainly dealt with the 6 days of creation, and we kind of touched on the nature of time in a peripheral way. We'll do more of that this week. But last week we started off by sharing some ideas from the excellent book written by the brilliant Professor John Lennox. He's written an excellent book called 7 Days That Divide the World. The reason for that title is that the Christian world is divided on the nature of the 7 days of creation, or the 6 days of creation. What are those 7 days, and which one of them God rested? So what are those 7 days? Are they 24-hour periods of time? Are there long epochs of time? Like we say, the day of the horse and buggy, like that kind of day. So this is why Lennox used that title for his book. So last week we shared some of the ideas that he touched on in this very, very good book in talking about the 6 days of creation. And we started off by saying that for a long time everyone believed that the earth was fixed in the center of the solar system and everything rotated around it. For many years. Many persons held this view. And not everyone, mark you, but many persons. And this view of the earth being fixed and not moving, first of all, it kind of matches with our perspective, with our perception rather, because we really experience the world as fixed, the earth as fixed. We are just here and we are just here.
Yeah, and as I said last week, some people say flat too.
Yes,
flat.
Right. So we experience it that way. And so that view of it being fixed and movable and the center of the solar system kind of matched with our perception of reality. However, in the 1600s, a very brilliant man and also a very rude man called Galileo Galilei, he threw some ideas of his, and other persons had held that idea too, but he expressed it in the most forceful way. And he ridiculed the church and the Pope at the time. He ridiculed them for thinking this. And he said nothing like that. He said the earth moved around the sun, and that was it. And so because of his ridicule of the Pope, who had this idea, the church had that idea, he was put under house arrest. And so, but he held on to his view. He said that the earth was not fixed. Okay. So nowadays, though, everybody knows that despite our perception, the earth is moving in several ways. The earth is spinning on its own axis. The earth is tilting, and the earth is moving around the sun, and the earth and the sun are moving. So all of that movement is taking place, despite our perception of being stationary. Absolutely. All of that movement is taking place. And so we then looked at
saying about in an hour you travel 1 million miles through space.
On the earth.
On the earth, yeah.
Right. But none of us feels that, you know. But nevertheless, that's what science says. Yeah. Okay, and the other thing we looked at is that when the Bible talks about the creation days, we have to, and the Bible in general, we have to remember that the Bible is not a book, a single book, but the Bible is a library of 66 books. And in looking at those 66 books, they are not all read or interpreted in the same way. Just like you wouldn't read a history book the same way as a poetry book. Because some books of the Bible are poetry, some are history. Okay? And so we also said that you have to take that into consideration, that poetry is read differently from history. Nevertheless, we said that when we are reading the Bible, including the creation story, we have to think about what did the author intend us to understand when he wrote that. And in that light, I would say that the author of Genesis, who was Moses, the author of Genesis intended us to understand those days in Genesis as 24-hour periods of time. Would you agree?
I would agree with that, although as we know, everybody does. Not
Everybody doesn't
everyone
agree with
it,
that.
but
Some people think
I
it's
certainly
not that
agree
at
with
all.
that. I
right.
certainly agree with that.
But
yeah.
I believe that based on how the days were described, evening and morning, that the author of Genesis intended us to understand those days as 24-hour
As I
periods of
say,
time.
I agree entirely.
Although the Bible uses the word day in different ways
Yeah.
within the Bible itself. Okay? Then the other thing we have to recognize, as we mentioned the last time, and John Lennox mentions in his excellent book, is that the Bible leans heavily on the use of metaphor, using words to describe something else. But the things that are described are real things,
Yeah.
but the way in which they relate are described in a metaphorical way, right? Not actual, literal way. And we have to remember that. And then we also said that the Bible's language is not scientific language. The Bible
is not a scientific,
it's not a scientific book, and the language is not scientific
all,
language
yeah.
at all. So we have to bear that in mind. And so we said that some persons take the view that the Bible and science are opposed to each other.
And they are not.
And they're not. We do not hold this view.
And let me just put it straight up. Science catches up with the Bible.
Okay, yes. You could say that.
Yeah.
So some people propose that, look, the Bible is saying one thing and science is always opposed to it, and you have to decide which one you're going to depend on.
Yeah.
You're going to look at science or you're going to look at the Bible. You can't have it both ways.
Yeah.
Naturally, we do not hold that view as scientists ourselves. Some persons say, look, I have nothing to do with science. I never went to college. Jesus gave me knowledge, and I get all my education from the Bible. It is equally a silly view, and it's not even a biblical view, and God doesn't ask you to do that. And Galileo himself said that. God gives you an intellect. Why wouldn't he want you to use it?
Yeah.
And Galileo also said that the story, the creation story, or the nature, the story of nature, is written by the hand of God in the language of mathematics.
Yeah.
So you need an intellect to read it, okay? But we hold the intermediate view, the view in between, that says that although not written in scientific language, but describing phenomena rather than scientific formula and so on, although not written in scientific language, the Bible does contain truth about objective reality. And science is the study of objective reality in the physical sense. Science is the study of the physical reality that we live in. And science really, when you look at it, is studying how God's handiwork works.
Yes, it's a study of the natural world, the mechanisms that cause the natural world to function.
Right, so what I'm saying is that there can be no natural animosity between science and the Bible, because science is a study of how what God has made works.
But there is very real natural animosity between those who have the atheist, materialist worldview and those like ourselves who have the theistic worldview, which believe that God made the world.
Yeah.
So science merely gives you information
about God's handiwork.
About God's handiwork. But the worldview, which is your view of the world, which is not science and must not be equated with science, it's a philosophical position. There is animus between theists and atheists, and the atheists try to make it look as though theists are completely without scientific positions.
Which is not true.
But it's good propaganda.
Right.
Yeah.
And so the more reasonable view to hold is that although not written in scientific language and although not itself a science book, the Bible does contain truth about objective reality.
It does, absolutely does.
And not only that, the Bible does something that science cannot do. That the Bible contains truth about meaning, about morality, what is right and what is wrong, and about purpose. And science can never address those things.
Well, in fact, the Bible is written just that. Why the world is, why is there a universe, and what is the purpose of the universe. Science is the study of the natural world that tells you how the universe functions.
Yes.
That's right. It doesn't tell you about
cannot address why
and
it's
the
here,
purpose.
cannot address morality, cannot address meaning, okay, or significance. And so this is why we see that both science and the Bible are important, okay? So we should avoid the extremes of one or the other. That's unnecessary. And also, the last thing we said is that we should not tie our belief in the Bible to the current scientific theory of the day, because that theory may change.
Absolutely.
And in fact, science, if it is really science, it ought to change if the evidence demands that it changes.
Yeah.
If something cannot change despite the evidence, it is not science, it is something else.
Yeah, okay.
Science, by its very definition, changes as the evidence changes.
Okay.
And so you should not discard your biblical faith, your faith in the Bible, because some scientific theory says something.
Yeah.
At the same time, you should not interpret the Bible in a way that is totally foreign to what science says. You don't need to do that. There is definitely a place where they both can complement each other, right? So we shouldn't ignore science, but at the same time, we should not make science allow us to insist that we discard our faith. And so when we're talking about the days of creation, then, which is how we started this, what is the day of creation? What were those 6 days and then the 7th day of rest? Over the millennia, different Christians have held different views about that. Some have said they are literal days of creation, and the earth is young. Some have said that. Some say, no, they are not literal days. They are large, long periods of time that we don't even know the length of that time. Each day could be 1,000,000 years or 1,000,000,000 years, and the earth is old. It's not young. So different Christians have held that view. And some, even within the Christian community, there has been some, some people have contempt for the other person's views.
Well, yeah,
So,
we try to avoid
even
that.
within the community. Some persons feel that other person's views are nonsense, like the young earth and so on. And so we came to the point then of talking about, in Genesis, we made some points that what is the light of the first day?
Yeah.
What was that? In the first day,
But let's hold that for the
Right.
time. Let's hold that for the time.
And we also said, should we read Genesis as history,
Yeah.
or should we read Genesis as a figurative way of describing what God did? So we are conveying timeless truths about God and creation, but we are using figurative theological knowledge. And the last video we showed last week then was a video by a man called Avin Ash.
Yes.
And he was talking about the dilemma of light.
Right. So this little mini seminar, look at it as a mini seminar that we're having. It's called the 6 days of creation and the nature of time. So that's a summary of what we did last time. And we started introducing the nature of time. But to understand the nature of time, we first had to look at light, because light, the phenomena of light, was fundamental to the nature of time. And in fact, we shared on a video by Avin Ash that light was first investigated, and the theory of light was formulated by a Scottish mathematician, physicist by the name of John Maxwell. And Maxwell was able to say that light actually is a fluctuating electrical and magnetic fields. Now, we don't need to go into that, but we'll be repeating a lot of what we say here just to help to clarify so that people understand. So John Maxwell, in his mathematical musings and equations, found that light must be fluctuating electrical and magnetic fields, because fluctuating and electrical magnetic fields travel at 186,000 miles per second, based on his mathematics. And people who were doing experiments on light found that light traveled at 186,000 miles per second, give or take a little bit in errors. So if you are working out something and you say fluctuating electrical and magnetic fields must travel at the speed of 186,000 miles per second, and you do experiments and you find that light travels at that speed, then you say that light is fluctuating electrical and magnetic field. But it's a wave, and the understanding of waves at that time, and even today, is that waves need a medium to travel in. And it was thought that there was this medium called the luminiferous.
By medium, mean a substance.
A substance. Just as my voice comes through sound waves, and sound waves are in air, and water waves, that when you go on the sea, they may have waves in the water on the sea. So they thought there must be some sort of thing to produce for the light waves to travel through. So for most of the 1800s, actually, people thought there was this substance they call a luminiferous ether that light traveled through. So you see how we're showing you how science changes over time. So experiments were done by Michelson and Morley to see if there was a luminiferous ether, because if you travel with a wave, you should go faster than if you travel
Against the
the wave. But they found that light traveled at the same speed. And not only that, other persons who measured the speed of light found that the speed of light, no matter what, was always a constant, whether you're going towards the source or going away from the source. Now, Galileo and Newton and these guys spoke of relativity. So if you're coming together at 60 miles, 40 miles, you're coming together at 100 miles. That's relativity. If you are going in that direction and this direction, and this is 60 miles an hour, 40 miles an hour, you're catching up at 20 miles an hour. That's relativity. But light wasn't showing relativity. No matter how you measure its speed, it was constant. So light did not have the features of relativity.
So you're saying that light did not behave like a wave, in the true sense of a wave?
Or in the true sense of anything that had velocity.
Right, because it's going along with the wave, you go faster than going against the wave, but light did not show.
Light didn't show.
One direction, the opposite direction, light was traveling in the same.
That's right.
So there was no ether through which light was going like a wave.
Well, the ether would have given you resistance. So
Yes.
if you didn't see that, you would say that there probably is no ether. But that's
Right.
only one problem. The other problem is why it is, no matter how you
The
measure
speed
light,
is constant.
why didn't light show relativity?
Yes.
So somebody
If
needed
you're
to
going
explain.
towards light or going away from light,
if
the
you
speed
measure
of
the
that
speed,
light is the same.
it's the same.
Okay.
So light did not show relativity. So Einstein is the person who answered that question.
theory of relativity.
And we're going to show you the first video in this today, how Einstein approached
The
to
problem
answer
of
that
relativity.
question of relativity with respect to light. Why light does not show relativity.
What did Einstein
So
find
we're gonna
out
see
about
it. We're
that?
gonna see it in the video. Let's get the first video. Okay.
Where Albert Einstein comes in. The term relativity had been around even before Albert Einstein, but it was thought of in a completely different way. The term had originated with Galileo Galilei. He and Isaac Newton had demonstrated relativity. So for example, if you're walking on a moving train and someone stationary in the ground is watching, your speed relative to that observer will be the sum of the speed of the train and your walking speed. This makes logical sense. But something seemed wrong with this classical interpretation of relativity as it applied to light. Just prior to Einstein in 1873, it had been recently proposed by James Clerk Maxwell that light was an electromagnetic wave, and he had calculated its speed, which was approximately 186,000 miles per second. Einstein knew this, and he came up with a thought experiment as a 16-year-old. His thought was to imagine that he was chasing a beam of light while traveling at the speed of light himself. What would he see? If young Albert could catch up to the beam, he writes in his notes, I should observe such a beam of light as an electromagnetic field at rest, though spatially oscillating. In other words, Einstein thought that he should see a stationary wave of light. Yet that was impossible. Einstein knew that such stationary fields would violate equations of electromagnetism developed by James Clerk Maxwell 20 years earlier. The laws were quite strict. Any ripples in the electromagnetic field have to move at the speed of light and cannot stand still. There are no exceptions. In addition, Einstein reasoned that if someone was traveling on a non-accelerating train at close to the speed of light, there would be no way for that person to know how fast he was going if there were no windows. This had been the classical view of relativity. Why should the laws of physics be different for a person traveling at some fixed velocity versus someone standing still? This seemed untenable to Einstein. So he came up with two postulates and tried to figure out what the physics would be like if the two postulates were true. Postulate 1 was that the laws of physics are the same for all inertial reference frames. This was part of classical relativity pioneered by Galileo. Postulate 2 was that the speed of light in a vacuum is constant for all inertial reference frames. The first postulate is pretty much common sense and had been assumed for hundreds of years. The second postulate, however, was the revolution. It was a consequence of massless photons moving at a velocity c in a vacuum. You would always measure a light's beam velocity to be 186,000 miles per second. This meant that young Einstein would never see the stationary oscillating fields because he could never catch the light beam. This was the only way that Einstein could see to reconcile Maxwell's equations with the principle of relativity. But this solution seemed to have a fatal flaw, and Einstein later explained this problem with another thought experiment. Imagine firing a light beam along a railroad embankment just as the train roars by, in the same direction at say 2,000 miles a second. Someone standing on the embankment would measure the light beam speed to be the standard 186,000 miles per second, but someone on the train would see it moving past at only 184,000 miles per second. If the speed of light was not constant, Maxwell's equations would have to somehow look different inside the railcar, Einstein concluded, and his first postulate that the laws of physics must be the same for all frames of reference would be violated. This apparent contradiction left Einstein spinning his wheels for almost a year. But then, on a morning in May 1905, he was walking to work with his best friend, Michel Bessot, an engineer he had known since his early student days. The two men were talking about this dilemma, and suddenly Einstein saw the solution. He worked on it all night, and when they met up the next morning, Einstein told Bessot, "Thank you, I've completely solved this problem." The solution to his thought experiment was that a person traveling on the train must experience time differently than the person on the embankment. Observers in relative motion experience time differently. And this was the moment of the revolution. It completely overturned hundreds of years of classical physics pioneered by Galileo and Newton, in which time was fixed and absolute in the universe. Einstein showed that time is relative and varies in different frames of reference. There is no absolute frame of reference that the ether was theorized to provide. Thus, the idea of the ether was no longer needed. This one realization that reality is not the same for different frames of reference also led to other implications of special relativity.
Right, so we are looking at Einstein's thought experiment. It is said, in fact, Einstein said he first thought of these experiments when he was 16 years old. Can you imagine that? At the age of 16, he said to himself, suppose I ran as fast as the speed of light, what would I see? And based on relativity, this is the concept of, if you are moving at the same speed, you'll be together. If you are moving towards each other, you'll be getting to each other faster, I said. But he found that if he were running at the speed of light, based on the understanding of relative motion and relativity, he should see a standing wave, a still wave of light.
Because they're going at the same speed.
Because they're going at the same speed.
So the relative speed between them is zero.
Is zero.
And so light will be standing still.
Light will be standing still. So that is what relativity, which is what Galileo and everybody and all the physicists of the day taught about relative motion. His thought experiment told him that he should see a standing wave.
So it's like if a car is driving along Hope Road
at 100 miles an hour.
And you are running 100 miles an hour, you would see that car as still.
That's right.
Because you and the car are moving at the same speed.
You're moving at the same speed, yeah.
And so he extended that thought to think about light,
About
like the
light,
car, putting
yeah.
light in the place of the car.
That's right.
And he said, if I were running at the speed of light, as far relative to me, light would not be moving.
It wouldn't
light
be moving.
Would be stationary.
It would be a stationary wave.
Okay.
But that conflicted with Maxwell's equation.
So light is never stationary.
Maxwell said light is never stationary to any observer, no matter what you're doing.
No matter where you are.
And no matter what you're doing, light is traveling at 186,000 miles per second.
Yeah.
So how did Einstein reconcile that discrepancy between relativity, what you expected, and what Maxwell said happens if it's light? So he did a second thought experiment, and the second thought experiment was to picture somebody on the train, which would be a different reference plane from somebody who is standing still outside the train. And he said, if you measure the speed of light, what would it be?
For those two persons.
For those two people. This train is moving at, let's say, I think in the video
miles.
they said 2,000 miles, whatever it is, the
per
train.
second.
But this train is moving at a speed, and the person who is standing up is not moving relative to. But the measurements for the speed of light
were the same.
Over various experiments were the same. And Maxwell's law also said it should be 186,000 miles for both persons, because Maxwell's law is one of the fundamental laws of physics, a law of electromagnetism. So if the person who is standing still and the person who is moving both going to see light
at the same speed, something is wrong.
Something got to give. And Maxwell, and since speed is distance over time, Einstein was bold enough to say, well, what gives us time?
Because speed is constant.
Because the speed of light is constant. So it must mean that the time for the person standing and the time for the person on the train is different. Now, that is a tremendous
that's kind of mind-boggling.
change in
Because
concept.
what does that mean? What would that mean for someone thinking about that?
Well, and because everybody, for all the time before Einstein, including Galileo and all the physicists, thought that for everybody the time was the same. 4 o'clock for me was 4 o'clock for you, was 4 o'clock for somebody in somewhere else, you know. So, in other words, and if you did an hour, I would also do an hour. If I walked from 4 to 5, my 4 to 5 would be the same as your
Okay, so let
4
us
to
say
5.
even somebody in England then, for whom it is now 8 hours later, right?
If
So it
they
is now
walk-
12 o'clock there. But if we say, if I say I am going to read for 1 hour, and the person in London says I'm going to read for 1 hour.
Well, somebody who's moving at a different speed from you. So the speed is the issue here. So if I am going to read for an hour, standing still, and you're going to read for an hour,
Moving
traveling
on a
at
plane.
half the speed of light, time for you is different.
Right, okay.
The hour that you actually
Whereas
spend.
we don't think so. We think that 1 hour is 1 hour for everybody,
Absolutely.
everywhere in the world.
That's right.
But Einstein was saying that, look, if I am stationary and I read for 1 hour,
that's right.
and you are moving,
and you read for an hour,
is that different hour?
a different hour. Time is different. Although if you have clocks in there and they measure it, they will both measure an hour. But the hour is different from my hour. And as you approach the speed of light, the difference becomes greater. So Einstein, and this is special relativity. You know, everybody says Einstein is a genius, but most people don't realize why Einstein is a genius. He stepped out of the way of thinking of time as being the same for everybody. An hour here, an hour for me traveling at 3 miles an hour is the same as an hour for you traveling at 100 miles an hour. It's different. It's different. So the question now is why? Well, Einstein never explained why that occurred, but what he did, like I said, is to raise that possibility and said that what we are experiencing here is that time is not the same for everybody. It varies according to your speed, your reference plane. And that's special relativity. That's what special relativity says. It says that things are relative depending on your speed of motion and the motion one next to the other. It took Einstein's maths professor, a fellow by the name of Hermann Minkowski, to understand that the reason why that is so is because we are not living in a moving three-dimensional entity, but we are actually living in a static four-dimensional entity. And we'll come to that.
Okay, so just to rehash, Einstein made a very bold move. What that mean? He had two truths that he had to hold. One, the speed of light is always the same, no matter where you are and what you are doing or how fast you are moving.
That's right.
The speed of light is always the same.
That's one of his. So if for any reason anybody finds the speed of light varying, the whole Einstein theory
would fall.
It collapses. Yes, because that's one of the assumptions of the theory.
Right.
The second assumption was that Maxwell's equations, being a fundamental law of physics, electromagnetism, will be the same
everywhere, for
whether
every
you're standing still, whether you're traveling
at the speed of light.
That's right. Whatever. Maxwell equations will be the same.
So in order to hold those two things together,
time
you have to say time cannot be constant because speed is a factor of
causes time to vary according to your reference plane. It is an incredible but he didn't come to it easily, you know. It took him a long time. In fact, when he pondered it, it took him eventually about a year, because what you're releasing a fundamental belief and something that everybody perceives.
Well, similar to the world thing.
Yeah.
Which I think is similar but much bigger. Yeah. It's a much bigger jump.
Yeah.
Because just from the
Earth being the center of the universe.
We are the center and everything circles around us.
Yeah.
To the fact that say no, not at all. You know, we are not the center of the Milky or the system at all. We are going around the sun.
That's right.
And we and the sun are both moving.
So people, like I say, it was a bold change in thinking, and people don't make bold change in thinking, particularly when, according to their perceptions, it is to the contrary.
So speed of light, as we're dealing with light now, the speed of light is always the same.
Always the same in a vacuum, yeah.
So,
always the same.
Speed is the distance that light travels
Yeah.
over the time it takes to travel that
Yeah.
distance. And since the distance of light travels, that's the distance you travel.
Yeah, for different people,
Yeah.
if you are standing still and you are moving towards it, it means that your time must be changing and the distance too. The time and the distance must be
Because
changing.
the speed is the same.
The speed is the
so
same.
the both time and the both numerator and denominator must
Must be changing.
adjust
That's right.
to keep that speed constant. Because
That's
if
right.
distance changes, time must change. Otherwise, speed will change.
Otherwise,
and
speed
speed cannot change.
That's right.
So this essentially is what he was saying.
So it is because distance and time have to
change.
adjust
First, keep
for
speed
to
constant.
keep speed constant. It means that distance and time must be related. They must be related.
One must affect the other.
They must be related. That's-
Otherwise, speed will not be
Otherwise,
constant.
speed will not be
Because
constant.
if distance changes and time doesn't change, speed will change.
Speed will change.
And speed of light cannot change,
Cannot change.
according to the laws of physics.
That's right.
So for the speed of light to stay the same, according to the laws of physics,
distance-
and distance changes, time must change.
So
too.
for different observers, distance and time
both
change.
must change
Both
to
must
keep
change.
speed constant.
That is incredible insight. But that is
Well,
pure genius.
For that kind of thinking, one could easily get put in a mental institution, I
Well,
think.
the
But anyway.
problem is that when you test the implications of the theory, it has come up to be true every time without fail. So Einstein did that. Well, we're going to show you that how Einstein related to some of the other physicists who also, they had all these bits of information, but they didn't pull it together. This is a short video to show you how Einstein thought outside the box, and he was brave enough to say what he said.
Some people point out that much of the actual work for special relativity had already been done by the time Einstein presented it. The concepts of time dilation and simultaneity for moving objects, for example, were already in place, and the math had already been developed by people like Lorentz and Poincaré. Some have even called Einstein a plagiarist. There's no doubt that the revolution of Einstein was built on the shoulders of other great scientists, and Einstein may have been given a lot more credit than others who did prior work. At the same time, Einstein still deserves the accolades because he took the bits and pieces of the puzzles found by others and put them all together into a whole new theoretical framework. He rejected the idea of the ether altogether, which other scientists had not done, and boldly proclaimed a new fundamental understanding of time and reality. And the idea of mass and energy equivalence via E equals mc squared is solely Einstein. Scientists who had done prior work like Thomson, Lamore, Lorentz, and Poincaré had never implied such a bold proposition. And just as in life, history tends to favor the bold.
Now, we know that Einstein was called dunce and told to leave school and so on by his professor
We saw that last
we
week.
saw that
yes,
last
he was
week.
least likely to succeed.
Yeah, least likely to succeed. But Einstein showed why it is important to never give up on your dreams. He, despite the fact that he was rejected in his school and rejected in his job application, he kept working at the issues. Secondly, he showed why it's important to think outside the box, because Einstein was the first person who taught the way Einstein taught in the history of human beings. Everybody thought an hour for everybody is the same, whatever speed you're traveling at. But Einstein said, no, if you are traveling at different speeds, an hour is different. And not only is an hour different, the distance you move, etc. is different. So he was bold. And as we see, other physicists had these ideas, and these problems were facing the world of physics. How do you reconcile the speed of light being constant and Maxwell's equation being constant? And Einstein said, well, look, he didn't say it easily. It took a long time, but after a year or more, but he said, look, it means time and distance must change.
And they are connected.
And they're connected. So therefore, if we're not moving, and like I say, Einstein didn't put this piece together. What we're going to talk about now, which we're going to show in next video, about what's called the block universe. That the universe is not merely us really moving in space through time, but it's a static entity made of time and space, which we move through and perceive as moving through time.
Okay, so
And that insight was by Hermann Minkowski.
Minkowski.
You know, the
Okay.
Jews seem to have a monopoly
yeah, they're
on these
blessed. Well,
brilliance.
there's no mystery about it. They're blessed. They're particularly blessed. So
Yeah.
Einstein was a Jew,
He was a Jew. Einstein was a Jew, and Minkowski
and so was Minkowski as well.
Minkowski was a Jew
yeah,
as
they
well.
have such special blessing. That's why they get so many Nobel Prizes.
But these things, I think, are inspiration from God. Tell you the truth.
Probably.
I think God put
Yeah,
these
but
things
but
in
the
mind.
point you're making though is that Einstein said, look, this is logical. Logic demands that I think this way.
Yeah.
And so even if my perception is not that, I must still follow the logic and say, logic demands that I think this.
Yeah.
Even if my perception is different.
Absolutely.
So even if the world feels flat and stationary to me,
Yeah.
and the studies and the data suggest that the earth is moving, spinning, rotating,
Yeah.
and tilting, I have to go with that.
You have to go with that.
Despite my perceptions
You must be
to the
bold.
contrary.
Must be bold enough to go with that.
And you can't seek to be popular because sometimes the idea might be popular.
Well, that's right. And in fact, remember, he wasn't even in the physics community. He was
Right.
just a
He was a-
clerk
yeah, yeah,
working
he was a-
as
he was a
as
nobody,
patent-
relatively a
patent.
nobody.
And he is presenting this to the physics community, all the physics professors.
So he would have been ridiculed.
Well, fortunately, there was a physicist, a professor, who recognized that there was
Who should not
something
be
to this.
ridiculed,
There
yes.
was something to this. And it's because of that, it became into the, and all the experiments proved that it's
So
true.
if the speed of a thing is constant, then distance and time must not only be both capable of changing,
Yeah.
but changes in one must cause change in the other.
That means that they're linked.
That they are
Somehow
linked.
or the other,
Because otherwise you cannot
somehow
keep
or the other, they are
you
linked.
cannot keep the fraction constant.
That's right.
Unless those two are linked.
That's right.
And this is what he was bold enough to say.
Well, he didn't go that far.
Oh, he didn't go
All
that
he
far.
said is that, listen, if the speed is constant,
Time cannot be the
time
same.
must change.
Time
And
must
if
change.
time change, distance must change too.
Right.
So that's Einstein.
Okay, that's
that
what
is
he
his
said.
contribution.
Oh, okay.
He didn't go beyond.
So Minkowski is who took it further.
Minkowski said
Okay.
further that these things are not only linked, they are part of a four-dimensional structure. And that four-dimensional structure is not moving, it is still.
Still.
And this is what the next video is
So
going to
we
tell
are going to
us
see
about.
what the four dimensions
What the
are
four
in this
dimension-
video.
Next
Okay.
video, yeah.
You're watching this video. Your brain cells are firing in anticipation. A story is unfolding. Time is moving forward. Or is it? What if I told you that nothing is happening? There's no story unfolding. The story has already been told. The video has already been uploaded. You're just watching it 1 second at a time. So there is a story unfolding for you only. What if your entire life was like this video upload, like a DVD? The story of your life is already on that DVD. The only difference is that you don't have a forward and reverse button. You're forced to experience your DVD 1 moment at a time. There is some strong scientific evidence that this may be the true nature of reality. If so, that would mean that everything you think you know is utterly an illusion. Let's look at what science has to say about this and its profound implications for existence. Coming up right now. Einstein's theory of relativity supports something called the block universe, which is really a four-dimensional space-time structure. This means that every event has its own coordinates, not only in space, but in time. So for example, wherever you are right now corresponds to a location in 3 dimensions, like London, England, and a location in time, 2 p.m., February 2nd, 2019. But just like the space 10 feet ahead of you is as real as the space 10 feet behind you, so too is the moment 10 minutes into the future and 10 minutes into the past. In other words, the past, present, and future exist just as much as the present. MIT physicist Max Tegmark says we can view the universe as a 3-dimensional space where stuff happens, or 4-dimensional block universe where nothing happens. If it is the latter, he says, then change is really an illusion because nothing is changing. It's all there, past, present, and future, like a DVD. A drama may be unfolding in the movie recorded on the DVD, but nothing about the DVD itself is changing in any way. We may have the illusion at any given moment that the past already happened and that the future doesn't yet exist and that things are changing. But the only reason we may have a past is that our brain contains memories of the past. If we did not have any memories, would we have any sense of the past or a sense of time at all? Is it possible that time doesn't actually exist except through our perception of it? Physics doesn't help us when it comes to this arrow of time. It is time agnostic. If time was running backwards, all the equations would still be valid. So mathematically, physics does not say that time goes forward or backward, It just says that time cannot be zero, but it can run either forward or backward without violating any laws. Time is symmetric. John Barber, a British physicist, describes time as a succession of pictures, a succession of snapshots. To Barber, change is real, but time is not. Time only exists because change is taking place, he says. But this is counterintuitive. Reality seems to be telling us that time does exist, and that its arrow points in only one direction, forward. Why doesn't the arrow of time flow backward if physics says that it is equally likely? It would have been possible if it were not for one aspect of physics, and that is the law of entropy. You see, entropy always increases. Entropy is a measure of the disorderliness of the universe. Things always get more disorderly. You can scramble an egg, but you can't unscramble it. This is entropy increasing. Entropy appears to be the only reason the arrow of time is what it is. But why is entropy always becoming higher? Why doesn't it become lower? There doesn't appear to be any fundamental reason for that. Alan Guth, professor at MIT who pioneered the idea of cosmic inflation, may have solved this riddle. He argues that information and entropy are almost the same thing. In order to know your past, you have to form memories. Adding memories means adding information. Adding information increases entropy. Therefore, a conscious system can only be conscious in one direction. Are we living inside a DVD? The block universe is allowed in relativity, but what does quantum mechanics have to say about it? Quantum mechanics says that time and space are the background or canvas on which existence takes place. So it does not preclude the idea of a block universe. But just because it is allowed in relativity and quantum mechanics doesn't mean that it's true. We need more evidence. If the universe is a DVD and all of time exists like points in space, then this implies that the future is as fixed as the past. This would imply no free will and superdeterminism. Do we have any additional evidence for this? Well, one solution to the mystery of entanglement is just such a universe with no free will. See my video on entanglement. So now we have possibly some evidence that seems to lead to the block universe scenario. This doesn't make it true, however, so the jury is still out on this. Physicists' opinions are divided. To many physicists, while we experience time as psychologically real, time is not fundamentally real. At the deepest foundations of nature, the flow of time is not required to construct reality. And if there really is no flow, then the block universe would reveal that all time and all space exists in tandem, and that our fate is sealed inside the DVD of the universe, and we are forced to view it without a remote control, one moment at a time. We cannot fast forward or skip a single moment. We can't reverse it. We might not even like the movie. It probably won't have a Hollywood ending, but it is our movie, and it is the only movie. We better find a way to like this movie.
So you should remind the viewers of what we are talking about today.
Yes, what we are talking about today is the 6 days of creation and the nature of time. So we've discussed the 6 days of creation already, and we're now talking about the nature of time. And we've recognized that special relativity, which is the theory that Einstein put forward in 1905, says that for different observers, times change. But time is not a constant.
Okay.
And Hermann Minkowski, Einstein's maths professor in 1908, 3 years later, said that although we think we experience ourselves moving through space in time, in actuality we live in this entity, which is a 4-dimensional entity, 3 dimensions of space and 1 dimension of time. How they are linked together, we don't know, but they are linked together such that it's a static entity,
so
and
by
it
the
doesn't
3
change.
dimensional space, you mean like height,
width and length. Yeah.
Right. So
those
those
are
are the
3
3 dimensions of space.
Yeah.
But there's a 4th dimension to make up the fourth side of that block.
That's time.
And that's time.
And somehow or the other, those
And
3
when those
dimensions
shift,
and time
they
are all interchanged, such that what you have is a fixed
Four
entity,
dimension.
which is what we saw in the last video.
Right.
So the question remains, how should we interpret the 6 days of creation? And although we have seen people try to adjust the days to make the day to fit with what science is telling us about the age of the earth and so on,
billions of years.
the Genesis account actually gives us a hint that that is a wrong approach. And the reason why we must not adjust the days, because the Genesis account is quite right. The days are equivalent to
Evening
24 days.
and morning.
Right. What we need to adjust, and this is our bold claim, what you need to adjust is not the days, but what did God create? Because we understand time as unfolding, so us moving through space in time that is going forward, we fail to appreciate that what the Genesis account is saying is that what God actually created is that static, completed 4D entity called the space-time continuum, which contains all the time, all the space, and all the matter that there will ever be.
Right. So you are saying, based on what we've talked about up to now, the days of creation, which you assert are real days, 24 days,
24
evening
days.
and morning, evening and morning. You're
But they
saying-
are measured by that light that God created on the
On
first day.
right.
They're not measured by the sun, which was
necessarily,
created on
the fourth day.
It couldn't be measured by the sun because
the
the
sun
sun
was
was
not
created.
there on the
So
first
that
day.
is an insight into what we are looking at is not measuring time based on the sun, but is measuring
Because
time.
the sun was not there for the first, second, and third days.
That's right.
was
It
there
is.
on the
We
fourth
must measure time based on this light that God created. He deliberately used that light, which was equivalent to the 24-hour days that we experience. But he used that light to measure the days of creation. And what he created is the space-time continuum.
So you are saying, we know that the Bible says, in the beginning.
Yeah.
In the beginning means that when everything began.
Yeah.
And everything except God, because God did not begin.
That's
right?
right.
So everything else except God had a beginning.
Yeah.
And in that beginning, you are saying that energy, matter, energy, space, and time were all created.
All the matter, all the time, all the space, etc.
all
were
the
created
energy
in those 6 days.
in that time.
In those 6 days. And then God rested.
Okay.
Because the whole thing was completed.
So you're saying everything was created at that time.
Yeah.
And we are living in that everything now.
We are living in that everything.
But we perceive it as January you get married,
Yeah.
December you go.
And December hasn't reached yet.
December's not got there. When December comes,
Yeah.
then you go to the US, and
Yeah.
then next year December you go to Canada.
That's
Just like how Galileo said, no, the earth is moving, although when you're standing in one place, you're standing in one place. You
Yeah.
don't feel any movement.
Yeah.
You are saying that although we experience the world like January 2020,
Yeah.
then December 2020,
Yeah, that's our
followed by
experience.
December, we experience life like that.
Yeah.
You are saying based on the experiments, the valid scientific experiments carried out, in the beginning, God created matter, energy, space, and time. Boom, like that. That's what you're saying.
Yes. And
All of it.
All of it. And in fact, Einstein's second theory, which is the theory of general relativity, which expresses how gravity is produced, which is an even better theory than Newton's theory. And it predicted exactly problems with the orbit of Venus, confirmed that we actually live in the space-time continuum. And that gravity is a distortion
Of that.
of the space-time continuum.
Yeah, gravity is not a force. That they thought gravity was a
No,
force.
it's not a force. It is a distortion of the space. And in fact, Einstein didn't believe in the space-time continuum initially. He rejected it. But in order to explain gravity, he had to accept
get back to it and
He had to
take
accept it.
Yeah.
So it's Minkowski.
So he wasn't all that bold after that.
Well,
Kinda gave up.
After a while, and in fact, he not only that, he had an
He tried to fix
equation
it, he tried to
which
fix
said
it.
that the universe was expanding. But he couldn't accept
didn't
that
accept
either.
it,
So he changed his equation.
So we're always going through the cycles of the
So-
same problem.
so
You have a
people-
perception,
Yeah.
and you mustn't tweak what you find out
That's right.
to fit your perception.
That's right.
You must change your perception
Yeah.
to match what you find
Absolutely.
out.
So like I said, he didn't agree with Minkowski, but he had to agree with Minkowski to come up with general
Because the
relativity.
evidence demanded
That's
it.
right. He didn't
didn't
accept
agree about gravity.
He didn't accept the expanding universe, but he realized that he fudged his equation to make the universe not expand. Because then remember, people thought the universe was fixed.
Yes.
And he thought so too. And so in order to stay with that,
So when he got information that demanded
Yeah.
an acceptance of its expanding
Right.
nature, he fought that.
before that. So
But he gave in after a
So
while.
we are postulating that what God made actually is the reality that we really exist in as expressed in special relativity and developed by Hermann Minkowski. What God made is the space-time continuum.
The block.
The whole block.
In which we
live
and move and have our being.
and have our being. But it is feeling like something that's expanded. Now the reason why it's important to say this is because when young people go to universities and college, they come across a challenge on the 6 days of creation.
Yeah.
But the Bible doesn't say that the days that were used to calculate the 6 days of creation were produced by the sun. It makes the point. It was done by another light. So we have to think outside of the box. And I think that the reality is, the Bible says that God rested on this after the 6th day, because the whole thing was done. The whole thing was finished.
Time included.
Time included.
That's it. That's a rub. That's a rub there.
The whole thing was
we
done.
all believe that matter was done.
Yeah.
That the earth,
Yeah.
the universe, the heavens and the earth, we
Yeah.
all believe that was completed.
Yeah, but we don't think that
That
time is completed.
matter was completed. But what you're bringing in is another concept to say not only matter was completed, but time was also
Time and space
completed.
are completed.
I think that time and space and matter were all
Yeah.
completed.
So we know we had some challenging ideas here, so we're going to leave you with a video that's going to make a summary of what we have done over the last couple of weeks.
But as we go, though, I just want to raise the point that the one person who will not experience the block universe as who would not experience it as moving through anything is God.
It's God.
Because God is not a part of time.
Not
He
a part
made
of time,
time
no.
along with matter and space. He
That's
made
right,
time.
yeah.
And so he made all the 4 dimensions. And
That's
so
right.
he would be external to all 4 of them.
That's
and
right.
so he would not experience it the way we experience
No.
it. And so this is why we can read things like saying that he knows the beginning from the end.
Absolutely. Yeah, we say it all the time. But
God
we do
knows the beginning from the end.
And
because
we sing about
in
it.
God's perspective and viewpoint,
Yeah.
both beginning and end are there.
That's right. The
And
whole thing
so
is there.
God experiences that as both beginning
Yeah.
and end, being both there.
Both
and he
there.
knows both.
Absolutely.
And a day with him is like 1,000 years.
Yeah.
And 1,000 years is like a day.
Yeah.
That means that time doesn't affect him at all.
Not at
It has
all.
nothing to do with him,
Not at
really.
all, not at
It's
all.
immaterial,
That's
actually,
right.
because he's outside of the time that he has constructed.
Absolutely.
In that
That's
block.
right. So it is said that at the Big Bang, space, time, and matter came into being. And that's why what we have is the space-time continuum. So we leave you, we knew some of the thoughts were challenging. We leave you with a video to recollect
Yes.
all the things that we have discussed.
Yes,
This has
and-
been the Isschar Hour.
Yes, thank you so much for joining us. It was our pleasure to have you. Please
Yeah.
remember to send, especially for this one,
Yeah.
please send your feedback and your comments or questions that you'd want us to explore further. But thank you so much. Invite a friend to watch with you the Isschar Hour. And please join us again another time as we look at other interesting topics in the Isschar Hour. Thank you so much for joining us.
Thank you. So we're going to be speaking about light, special relativity, and the 6 days of creation. We're going to put all that we have done so far together. So light, what is light? Well, James Clerk Maxwell, sometime in the 1800s, he was a Scottish scientist in the field of mathematics and mathematical physics. And his most notable achievement was to formulate the classical theory of electromagnetic radiation, bringing together for the first time electricity, magnetism, and light as different manifestations of the same phenomenon. Now, Maxwell's equations for electromagnetism have been called the second great unification in physics. Around 1862, while lecturing at King's College, Maxwell calculated that the speed of propagation of an electromagnetic field is approximately that of the speed of light. He considered this to be more than just a coincidence, commenting, "We can scarcely avoid the conclusion that light consists in this transverse undulation of the same medium, which is the cause of electric and magnetic phenomena." We're getting this from Wikipedia. So working on the problem further, Maxwell showed that the equations predicted the existence of waves of oscillating electrical and magnetic fields that travel through empty space at a speed that could be predicted from simple electrical experiments. Using the data available at the time, Maxwell obtained a velocity of 310,740 let me repeat that. 310,740,000 meters per second. Okay. In his 1864 paper, A Dynamical Theory of Electromagnetic Field, Maxwell wrote, "The agreement of the results seems to show that light and magnetism are affectations of the same substance and that light is an electromagnetic disturbance propagated through the field according to electromagnetic laws. Now, two gentlemen, one by the name of Michelson and the other one by the name of Morley, did an experiment, and it was an attempt to detect the existence of the luminiferous ether, a supposed medium permeating space that was thought to be the carrier of light waves, because people knew that sound waves were carried in air, for example, and waves in the sea were carried in water. So they said there must be some medium through which light waves were carried, and they called this the luminiferous ether. So they did an experiment, as we saw in a previous video, in which with waves that moved with or in the direction of theoretical motion of the ether, and waves that moved in a direction opposite to or perpendicular to the movement of the ether, they should have different speeds. But the experiment was performed between April and July 1887, and they found that there was no difference whatsoever in the speed. It was independent of the direction that the light beam traveled. So the experiment compared the speed of light in perpendicular directions in an attempt to detect the relative motion of matter through the stationary luminiferous ether, as they called it. The result was negative in that Michelson and Morley found no significant difference between the speed of light in the direction of movement through the presumed ether and the speed at right angle to it. This result is generally considered to be the first strong evidence against the then prevalent ether theory, as well as initiating a line of research that eventually led to special relativity, which rules out a stationary ether. Because we know that speed is distance divided by time, it was taught because of Maxwell's equations, which showed that light always moves at this speed in a vacuum. It is never stationary. It was thought that the speed of light is going to be constant for all observers, but that went against relativity, which relativity said that the speed would depend on how you're moving relative to each other or to a particular source. So that needed to be explained. Since speed is equal to distance over time, and the speed of light is considered a fundamental constant of nature nowadays, it is considered to be one of the things that is constant. The speed of light never changes in a vacuum. Its significance is far broader than its role in describing the property of electromagnetic waves. It serves as the single limiting velocity in the universe, being an upper bound to the propagation of speed of signals and to the speed of all material particles. In the famous relativity equation, which is E is equal to mc squared, the speed of light serves as a constant of proportionality, linking the formerly separate, disparate concepts of mass and energy. Nobody thought that mass and energy were related. But how did we come to link all these things together? And that is where Einstein comes in. So Albert Einstein, his first thought experiment was as a 16-year-old, so he says, what would happen if he ran at the speed of light? According to relativity, then he should see a stationary beam, because relativity says that if you're moving at the speed of light, that you would see that light as stationary. It should not be moving. But Maxwell's equation said nobody ever sees the speed of light as stationary. The speed of light is always this constant. So there was a discrepancy. How was Einstein going to deal with this discrepancy? To do that, he did a second thought experiment. And in this experiment, he said, look, if people in a train are traveling at, let's say, four-fifths the speed of light, and somebody who was standing was stationary, so they had zero speed relative to the speed of light, let us say, and a lightning bolt struck a tree, what speed would they measure the speed of light to be? And based on, of course, Maxwell's equation, they should both measure the speed of light to be, in terms of miles, 186,000 miles per second. Now, if that were to hold true, because of a second consideration, which Einstein thought to be true, which is that laws of physics, of which Maxwell's law is one, that light travels at 186,000 miles per second, would apply to both the person who is still and the person on the train. So Einstein said, well, look, let us accept that the speed of light is indeed a constant. Let us accept that Maxwell's laws, which is one of the fundamental laws of physics, is the same for everybody, whether they are on the embankment and stationary or in the train and stationary. So if those two things are indeed true, it must mean that something has to give. And what gives is time. It must mean that the time for these two observers is not the same. The time for the person on the train and the time for the person on the embankment must be different. And of course, since speed is equal to distance over time, it must mean that distance must change as well. So special relativity came to realize that time is not the same for all observers. It varies according to the movement of the speed of movement of the observer. From that, Einstein's maths professor, a gentleman by the name of Hermann Minkowski, came to realize that if that is the way that space and time were related to each other with respect to a beam of light, it must mean that our concept of moving through three-dimensional space in time must be wrong. But really, we live in an entity which is static, which was called the block universe, or the space-time continuum. Space-time continuum is to be distinguished from space and time. When you say space and time, you say you are living in three dimensions, moving through time. In the space-time continuum, you are in a block, and in that block, it's made of space and time. So all of time and all of space is in there. And this diagram, which is by Dr. Christy Miller for Catalyst, ABC Science, we see that a moment, what we call now, is really just part of the block. And so we come to the consideration, what did God make? We have been taught to think that we are living in space, moving through time. But special relativity, which led eventually to Hermann Minkowski's consideration in 1908, actually says, no, we're not living in space and moving through time, as is depicted here, where this would be the beginning, and we're moving through time. But rather, we are in an entity which is complete, and this is the block universe. So we are saying that we need to change our perspective once again. Just as the sun doesn't go around the earth, but the earth spins on its axis. We are not moving through time in space. We are actually in space-time. What God made in 6 days is the block universe, the complete and total creation that there ever will be. All the space, all the time, and all the matter. That is what was created in 6 days. So this is the change in perspective we need. From our perspective, we live in an entity that's unfolding in this direction, started up here, but is unfolding in time in this direction. But from God's perspective, we live in an entity that is completed, absolutely and totally completed.